I think I'm live now, right? Okay. Yeah, I think you can see me now. Okay. Yes. Everything is perfect. No. Okay. Okay. Let us go by random problem solving, right? Let me filter the status is to do the problems which I haven't solved, and the difficulty to hard, and the topics is not, I'm not sure or perfect with the try concept. Okay, let us see. Okay, there are many concepts. Okay, let us see. It is based on, based on the numbers. Yeah, let me know which problem you want me to solve. Regular expression matching, reverse nodes in K group. Okay, I think that's a graph problem. I think reverse nodes in K group, longest valid parenthesis, wildcard matching permutation sequence. Let me pick a random one. Add 751. Pick one. Okay. I'm just picking a random problem. Let us see whether data stream has disjoint intervals. Firstly, okay, let us see what are the topics here. Hash table minus search. Okay, everything is good. It is a design problem, actually, a good problem. All right, let us see. Data stream as disjoint intervals. Given a data stream input of negative, non-negative integers a1, a2, and so on to an, summarize the numbers seen so far as a list of disjoint intervals. Let us see what are these disjoint intervals. Implement the summary ranges class. Summary ranges initializes the object with an empty string. Void add num into value adds the integer value to the string. Int get intervals returns a summary of the integers in the string. Currently has a list of disjoint intervals. Start of I, comma end of I. The answer should be sorted by start of I. Okay. Summary ranges add num. Okay, let us see what it is. Summary ranges. Okay. Add num 1 and then get intervals. No. Get intervals 1 comma 1. 3 comma 3. Disjoint intervals. Okay. Let me see the explanation. New summary ranges. Okay, it has fixed. Now summary ranges dot add num of 1, array will be 1. Now, for get intervals, return 1 comma 1. Okay. Add num 3. So array is equal to 1 comma 3. Get intervals 1 comma 1, 3 comma 3. Add num 7. 1 3 7. Now get intervals, return 1 comma 1, 3 comma 3, 7 comma 7. Add num 2. 1 2 3 7. Okay. Get intervals 1 comma 3, 7 comma 7. Okay. There is something which I'm missing. Yeah. Add num 6. 1 2 3 6 7. Now 1 comma 3, 6 comma 7. Okay. First, we have pushed back 1. We are asked for 3. Okay, we have pushed back 3 again. 1, 3, 7. So when, okay. And then we are asked for 7. Okay. Now when we are, okay. Okay. So the disjoints interval means, I think it as, let me tell you, let me, so the acceptance rate is 60% approximately. First thing, first thing, let us see what is the disjoint interval. Disjoint intervals meaning set of numbers or terms that have no points in common. They don't overlap at all. Meaning if you have a comma b and c comma d, either b is less than c or d is less than a. For example, and are disjoint, but and are disjoint, but and are not because they share numbers like 4 and 5. 1 3 and 4 6 are disjoint because they do not share any common points. 1 comma 5 and 4 comma 6 are not disjoint because they overlap at points between 4 comma 5. Now what happened here is 1 comma 1. Okay, now I have 1 comma 3. I am returning 1 comma 1, 3 comma 3. I have 1 comma 3 comma 7. I pushed back 7 and I am returning 1 comma 1, 3 comma 3 and then 7 comma 7. I'm asked to push back 2, so I got 1 2 3 7. Now okay, 1 comma 1 comma 1 2 comma 2. Why can't I return 1 comma 1 2 comma 2 3 comma 3 and 7 comma 7? That's what I am having the uh, confusion here. 1 comma 1 2 comma 2 3 comma 3 and 7 comma 7. Okay, let us see what changed here. 1 3 and 7, they aren't consecutive, right? But here 1 2 3, these three are consecutive. So I think I'm pushing this 3, the one which is in okay, yeah. Okay, first first let us see first. I have the array as just 1. Then I have array as 1 comma 3. Okay, then I have array as, excuse me, 1 comma 3 comma 7. 1 comma 3 1 comma 3 comma 7, 1 2 3 7 again. 1 2 3 7, right? So then okay, array is 1 comma 2 comma 3 comma 7. Now let me remove this and also this. Now 1 2 3 6 7. Then I was having 1 2 3 6 and 7. I'm thinking something like, so I have 1. I doesn't have the next number, so I'll just return 1 comma 1. I have 1 comma 3. If I had 1 comma 2, I'll just return 1 comma 2 as it was, right? But if it is not consecutive, right? 1 comma 3 is not consecutive, so what I will give is 1 comma 1 and 1 comma, sorry, 3 comma 3. Now if I had a 4 here, I would just return 3 comma 4. But I don't have like that. I'm just thinking this is the way I can solve the problem. Now let's go here. 3 is not the next number to 1, so okay, 1 comma 1. Now 7 is not next number to 3, 3 comma 3. Now 7 comma 7. And now here, okay, when I have something like this, I need to check, is it okay, okay, wait a second. Okay, my algorithm is something like, I'll be pointing an I pointer here. I'll check whether these two are consecutive, right? Yes, they are consecutive. I'll just move that to the next number. And here is our previous, right? Previous is 1. Now, is I and these two are consecutive? I'll check. So yes, they are. So the I will be moving forward. Now, is the last one and the current one are consecutive? No. So what I'll do, I'll just push that previous array of previous and also array of I minus 1 into the answer, right? Now, okay, I have done that. Now, uh, now after pushing that back, previous I will become my previous. Okay, let me tell you what I am doing, right? So previous will be at 0 and I will be at 1. So let me start with I will be at 1, sorry. So I, okay, I is equal to, okay, let us see how can we solve this clearly. I got 1 comma 3. Let me take this 1 comma 3. So here is my previous, here is my previous, here is my I. Now is I minus 1 is equal to I, the value at I minus 1 equal to I? No. So what I'll do, if array of I minus 1 is not equal to array of I, first thing, uh, first thing is array of previous, array of previous comma array is not equal to array of I minus 1 plus 1 is not equal to array of I. Plus 1 is not equal to array of I. Then array of previous and array of I minus 1. I'll push that back into answer. Okay. But else I'll just increment my I pointer. Right? Let us see. Let us see whether it works or not. I plus plus and the previous will be I. Previous is equal to I. Else I plus plus. Let us see. Let us see. So the answer array is empty. Now the previous is at 0 and I is at 1. Now array of I minus 1 plus 1, I minus 1. is 1 plus 1 is 2. Is 2 is not equal to array of I. 2 is not equal to 3. Yes. Answer dot pushback array of previous. Array of previous is 1. Array of I minus 1. Okay. Array of I minus 1 is 1 itself. So this will be one thing. Now I need to have something, a number like minus 1 in the end of the array, so that I will be here and the previous will be here. 3 plus 1 is not is equal, 3 plus 1 4 is not equal to minus 1. So 3 comma 3. Now let's take another array, do the same thing again here, 1 comma 3, and I got 7. If you clearly observe, 1 3 and then 7, so I will be having another number minus 1. Let us see. Answer is empty initially. Answer is empty initially. Data stream as disjoint intervals. Let me place it like this so that you can understand it. Okay. Okay, no. 137 minus 1. The previous pointer is here and the I is here. Now, array of I minus 1 plus 1. 1 plus 1 is 2. Is not equal to array of I. Is not equal to 3. Right? 2 is not equal to 3. Now, answer dot pushback array of previous. Array of previous is 1. Okay. Array of previous is 1, comma array of I minus 1. I minus 1. 1 minus 1 is 0. It is 1 itself. Okay. I am pushing that back. Now, previous is equal to I. Okay, previous is equal to I. Even then, I'll increment the I pointer. So I will be here. Now, array of I minus 1, 3 plus 1. Array of I minus 1 is 3. 3 plus 1 is 4. Is 4 not equal to array of I? I is 7. Yes, 4 is not equal to 7. Now, answer dot pushback array of previous. Previous is 3. Array of I minus 1. I minus 1. Array of I minus 1 is 3. So 3 comma 3. Now previous is equal to I. So previous is equal to I. Now I will be incremented here. Now array of I minus 1, 7 plus 1 is 8, is not equal to array of I minus 1. Yes, they both are not equal. So if you see, answer dot pushback array of previous is 7. Array of I minus 1. I minus 1 is 7 itself. Yes, we are going in the right direction. Let us add 3 here, so that 1 2 3 6 7, right? Okay, wait a second. 1 2 3 6, sorry, 1 2 3, and then I got 7. If you observe here, 1 2 3 7. Yes, 1 2 3 7. I got 1 3 and then 7 7. Let us see whether it is correct or not. Okay, let us start. The previous is here. I is at 1. Array of I minus 1. Array of I minus 1 is 1. 1 plus 1 is 2. Is 2 is not is equal to array of I? 2 is not equal to 2? No. 2 is equal to 2. So it is false. I plus plus. So I is here. Now, array of I minus 1 plus 1. 2 plus 1 is 3. Is not equal to 3. No, it is false. So I plus plus. Now this is false. 4 is not equal to 7. Answer dot pushback array of previous is 1. I minus 1 is 3. 1 comma 3. Now previous is equal to I. Previous is equal to I. Now I plus plus I will be here. As I said, -1 will be pushed back every time. So I will be here. Now, array of I minus 1 plus 1, 8 is not equal to -1. Yes. So answer dot pushback, array of previous is 7. Array of I minus 1 is also 7. I think we are correct. 1 comma 3. So when I have 1 2 3 7 here, I got 1 comma 3 comma 7 comma 7. We are going in the right direction. Let us take 1 2 3 6 and then 7. 1 2 3 6 and then 7. Okay, previous is here, I is here. Now this is false, right? 1 and 2 are consecutive. 1 plus 1 is 2 is not equal to 2. No, false. This condition doesn't satisfy. You are using this graphical tablet, which you are using that graphical tablet. I am using HUION, bro. Let me write it here. Radha Krishna, bro. So which one? I think you are asking which one I am using. It is HUION HS64. I am using this tablet for writing. I think you are clear. Your dot is clear, bro. Yeah, let's come back. HUION HS64. So there will be live sessions every month. So if you have any doubts, please let me know, and can we hit 1,000 subscribers before we end this session? That's what I'm hoping for. Yes. Okay. So the P is here, previous is here, I is here. This condition is false. Answer dot pushback. Answer. Wait a second. Answer dot pushback. No, this condition is false, so this doesn't execute. I will be changed to here 3. Now 2 plus 1 is not equal to 3. This condition false. It doesn't satisfy. Now I will be incremented to 6. Now 3 plus 1 4 is not equal to 6, right? So what I'll do, I'll just push back. Array of previous is 1. Answer is equal to previous is 1, and array of 5 minus 1 is 3. No. Okay, previous is equal to I. Now I plus plus. Okay, array of I minus 1 is not equal to array of I. Here comes the actual problem. Yeah, let me tell you. I think there will be no problem, such as, okay, here I will be having -1. Array of I minus 1 plus 1, nothing but 6 plus 1. 7 is not equal to -1. Yes, it is true. Now answer dot pushback. Array of previous is 6. Array of I minus 1 is 7. Is it really? Yes. 1 comma 3 and 6 comma 7. Yes, this one works. I think at most 10 or 2 calls be made to get intervals. At most 3 calls we made to add num and get intervals. Okay, 3 into 10 power 4, the constants. What if there are lots of merges and the number of intervals is small compared to the size of the data string? I think I'm going in the right direction. Yes, we have solved the problem. So the approach is very simple. First thing, we need to have the array. So it's just like an intervals. It's a quite easy problem. I don't know why they have marked it as a, a harder one. 0 comma 6 comma 6. If you have something like this, the mistake which I made is I didn't put this one. Array of I minus 1 is not is equal to array of I, right? If they both are not equal, and also they both are not consecutive, right? Yes, it will be like this, and then 6 7 8 8. Okay, this is one thing. 10, yes, it will be like this, and then 6 7 8 8. Okay, this is one thing. 10 comma 10. Okay, this will be like this. And the another one, let me take another one. If I have another element 11, it would be like this. Now the interval or the distance set will be 1 comma 4, excuse me, 1 comma 4, 6 comma 8, 10 comma 10, 11 comma 11. I think you got it. If you have any doubts, please let me know in the comment section. Yeah, we'll be moving to the next hard problem. I think it's just, I don't know how much time it you are using. Only 33 minutes, right? It was only 33 minutes which we solve this problem. There will be this thing, I think. The time took for the no. Okay. Let us see. Let us look at another problem. No. Here. Let us pick one problem from this. Okay. This one is interesting. First, find longest awesome substring. Problem number 1542. You are given a string S and an awesome substring is a non-empty substring of S, such that we can make any number of swaps in order to make it a palindrome. Okay, such that we can make any number of swaps in order to make it a palindrome. Return the length of the maximum length or some substring of S. I think we just need to wait a second. We just want every digit to be repeated for even number of times in the substring, and one digit to be repeated only one time. I think so. How do you make a substring? Leave the middle character. These two are equal. These two are equal. These two will be equal. So the strings should be something like, we need to make the substring into any swap so that it could become a palindrome. Now there will be a middle character which is not uh, equal to anything, or it can be any digit from 0 to 9. Now I can also have a palindrome like this. These two are equal. Wait a second. These two are equal. These two are equal, and then these two are equal. Right? Yeah. There are only two types of palindrome. Yes, there will be only two types of palindrome. 1542. Find longest awesome substring. Find longest awesome substring. Okay, it has marked as hard. I think so. Yes, it is having acceptance rate of 46 percentage. No, no, I'm thinking like for this, the criteria is all digits. One digit should be repeated one time. One, okay. One digit should repeat odd times, like 1, 3, 5, 7, something like. Remaining all remaining all should repeat even times. I'll tell you why. If there is a number 3, digit 3 repeating for 5 times, and there is a digit 1 repeating for 2 times, and there is a digit 2 repeating for 4 times, I can definitely make a palindrome out of this. I'll tell you how I can make it. Okay. Now, firstly, I would place this 3 in the middle. Now, how many threes I have? 4. So, two threes on the left, two threes on the right. I have two ones, one and then one. Four times. Two is repeated for 4 times. 4 times. Two is repeated for 4 times. Two, 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 two. This is the middle three. Three, 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 one, one, two, and then two, two, and then two. This is a palindrome, right? Now imagine there is another type of palindrome. There will be another type of palindrome where you have one for 2 times, and 8 for 4 times, and 6 for 2 times. Now I can also make a palindrome from this, right? I can make it like 1 and then 1. 4 times. 8 is repeated for 4 times. 2 times on the left, 2 times on the right. 6 for 2 times. 1 6 on the left, 1 6 6 on the right. From the middle, 1 and 1, 8 and 8, 8 and 8, 6 and then 6. Okay, this is the palindrome. There are only two types of palindromes in the world. The middle character will be different. Uh, right middle character will be odd number of times, or yes, middle character will be repeated for odd number of times, and the remaining will be repeating for even number of times. Or here, all digits are repeated even times, even number of times. Is my voice audible to you? Yes, I think my voice is audible to you. Yeah, if you have any doubts, please let me know in the comment section. Chandran bro, thanks for subscribing to our channel. Thank you very much. And the goal for today's goal is, can we hit 1,000 subscribers? It is just 90 people. It is just 90 people. 90 coders, so that we can have 1,000 subscribers before this day. All digits are repeated even number of times, or only one digit is repeated odd number of times. Let us see. Let us take an example. Let's take an example. No need to hurry when we hit a hard problem. We need to go layer by layer. 3, 2, 4 2415. Okay, okay. Ending at here, I can make a palindrome of length 1. Okay, I can make a palindrome of length 1. Ending at here, I cannot make. Even then, I can make only a palindrome of length 1. Here, even then, I can make a palindrome of length 1. But here, here, if you see, okay, okay, let us see. Let us assume digits repeating odd times. Digits repeating even times. Let us place all these things here. Digits repeating odd times. What are those digits repeating odd number of times? Odd number of times. Those digits are 3 and 4. 3 and then 4. Digits repeating even number of times. 2. And how many times is it repeating? How many times is it repeating? Yeah, 2 is repeating for two times, right? Now there is an odd things like this. It's repeating odd times, right? This is a palindrome, right? Okay, okay. Let me go to the next element here, 4. 4 is repeating for two times. No, 4 is not repeating for one time. 4 is repeating for two times. Now, what is the longest? Okay, okay, okay. I need a substring, right? Yeah, I cannot go like this. It is not a subset. We cannot go like this. Yeah, we cannot go like this. 10 power 5. Okay, we cannot. I am going by the subset theory, right? By just taking the digits. By just taking the digits, right? So we let us start again. No matter, no matter. Okay, let us start again. We'll be taking a break after 15 minutes at 6 p.m. sharp. No, I think we can solve this by using a sliding window. No, bit manipulation. Okay, bit manipulation. Why we need a bit manipulation here? We're not asked for any subset, right? Bit masking. It is not bit masking. It is bit manipulation. Okay, 24241. 24241. Okay, let us just do a. Let us just do a brute force approach here. The problem is find longest awesome substring. Yes, 3242415. For I is equal to 0, I is less than n. For j is equal to 0, j is less than n. Not j is equal to 0, j is equal to I. Here also, no, wait. I cannot sort the string, right? I will be I will be missing the order. Okay. I'll be having an unordered map. Let us see. So in the unordered map, I think I need the maximum odd every time, and also events. No. Okay. Let me take 3 2 4 2 4 1 5 3. 3 is for only one time, max odd is 1. 2 is for only one time, max odd even updated. Right, 4 is for only one time, 2 is for two times. Events will be 2 now. Events, the digits which are repeated even number of times. Okay, let's go. 4 is for two times. Okay, let me increment to this to 4, and then let me take 4 and then 4 again. Let us see what will happen. Okay, 4 is for two times, max odd. Okay, 1, I got 1. 1 is for one time. I got 5. 5 is for one time. 4 is for three times. Okay, now the max odd is 3. Now how many events I have? Here comes the actual problem. Here comes the actual problem, right? The events I have, uh, yes, it is not 4 anymore. It is not 4. So if I got, yes, if I got a number, if I got a digit having even frequency, having even frequency, let's come back. If I got a digit having even frequency, that digit will become odd frequency. No. So events minus is equal to MP of the digit. Okay, that's quite fair enough. Events minus is equal to MP of digit. Yes. And the max odd every time. Max odd is max of max odd, comma, MP of digit. Now, okay, there is another problem. There is another problem with this. I have, yeah, that's, if I have this another 4, something like this, another 4 is even number of times. Okay, which is even number of times. What will I do now? Now at this point, what will I do? Events will, yeah, okay, events will be incremented by 1 every time, right? Okay, let us see. What if I just take 1, 1, 1, 2, 2, 2, and then 2. Max odd and events I need. max odd events. One is for one time, so the max odd is one. One is for two times now. Now the max odd is not one. If you carefully observe, the max odd will not be one. That's the problem. Yeah. So let's see. Let me tell you one thing. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Okay. To sort this, it will be a constant time. It is not much greater, right? So s dot length s consists only of digits 0 to 9. Okay, that's a good thing. What if I just traversed it and got max, odd, and events? That's a great idea. I don't know whether it's a great or just a normal idea. For I is equal to 0, I is less than n, I plus plus. Let me tell you one thing. Let me tell you one thing. For j is equal to I, j is less than n, j plus plus. I'm just incrementing vector of int with the 10, array of 10 comma 0. Every time I'm initializing for every I. For every I am initializing it. Okay. Okay. Let's wait a second here. Now, now the digit. So here it is s of I, right? Array of s of I plus plus. Here I will write for int k is equal to 0, k is less than 10, k plus plus, array of s of I plus plus, and here max odd is equal to 0 and events is equal to 0, right? Okay, now if array of k mod 2 is nothing but if it is odd, max odd will be updated. Max odd is equal to max odd comma array of k. Okay, else events plus is equal to array of k. Now this for loop ends and answer will be maximum of answer comma max odd max odd plus events. That's it. Answer is equal to 0 initially and we'll be returning the answer. This is just a brute force. I'm not saying this will be the answer or the solution for this problem. Let's start. Int answer is equal to 0 for int I is equal to 0. I is, wait a second. Let's take n is equal to s dot size. I plus plus. Okay. No. Vector of int. Okay. Sorry. Array of 10. Size 10 comma 0. Now for int j is equal to I, j is less than n, j plus plus. Array of s of I plus plus minus 0 plus plus int max odd is equal to 0 events is equal to 0. For int k is equal to 0, k is less than 10, k plus plus. If array of k mod 2 max odd is equal to maximum of max odd comma array of k, else events plus is equal to array of k, right? And then answer is equal to maximum of answer comma max odd plus events, return answer at the end. It's giving me 7 4 to 4. Let me run that. Wait a second. It is giving me the whole as the answer. Max odd, max of max odd, comma array of k. Okay, let us see. I need to ask, sorry. So, no. S of j, sorry. Here also S of j. This won't be running actually. Why? Because it is big of n square. The time complexity is big of n square, right? It won't be running for the constants like this 10 power 5. But there is a chance we can optimize it, but let us get the wrong answer first. Let us get the time limit exceeded 1. If you are new to our channel, please do like, share and subscribe to our channel. We'll be having the live sessions every time. Wrong answer, yeah, okay. 9498331. Expected 3, but output is 5. Let's see what is the max or even did I get? Events 4 and max odd is 51. Let us see. Okay, we got. I did the same mistake of taking the. I made the mistake of considering all the odd numbers but taking only one max odd. Yes. So uh, why I don't go like only considering the substrings which have only one odd. A substring is awesome. That's it, right? Let us write all the characteristics. A substring is awesome if it has only one digit with odd repetitions, odd frequency. If it has only one digit with odd frequency. I don't care about the remaining, uh, I don't care about the remaining or even or whatever it might be, but the substring should have only one digit with odd frequency. But how do I get the substring? Imagine a string like this one, two, whatever it might be. Here, I start from here. I is here and J is here. Now, I'll be having 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there will be one digit. There will be one digit. Let's take the digit as 9. So 9, the frequency is 1. I'll traverse through this, and how many digits are having odd frequency? Only one digit. Get that. Odd. No need of this. Why? Because there will be only one digit with odd frequency and the digit will be used. Okay, leave that. Not one digit, at most one digit. If it has only at most one digit, at most one digit with odd frequency, 0 or one digit with odd frequency. Okay, yes, then the J will be pointing to here. So every time I need to count through this array, count array. Okay, let us see. J is equal to I, J is less than n, array of S of J minus 0 plus plus. Now odd count is 0. Okay, odd count is 0. Array of k mod 2, then odd count plus plus, right? So if odd count is greater than 1, then just break the itself. Now if odd count is lesser than 2, then answer is equal to max of answer comma j minus I plus 1, right? Let me run this. Yeah, it won't be running for only 5 test cases. It will be having big of n square time complexity. So yeah, the time will be exited as expected. Now let us use a sliding window and try to solve this. So the goal is in sliding window, the goal is the odd count, odd uh, the elements with odd frequency. The elements with odd frequency should be less than 2, nothing but 0 or 1. Okay, I think you understand the logic here. If there are two digits with odd frequency, then we cannot build. Wait a second. 1 1 1. Yeah, we cannot build a palindrome with two or more digits with odd frequency. Okay, the elements with odd frequency should be less than 2. That's what the goal is. So L will be 0, R will be 0, while R is less than N. Um, Let's just take array of s of r plus plus. Okay, why? How do I get the odd count? I'll get it by writing get odd count of this array. So get odd count of this array. Now, wait a second. So get odd count of this array. If it is greater than 1, then array of s of l minus minus and l plus plus, I think that's it, and r plus plus. How do I get odd count from the array? Just int get odd count of the array is nothing but if I'll just loop the array int count is equal to 0 for int num in array if it is odd num mod 2 then count plus plus. Okay, return count. Let me write this. We'll be meeting tomorrow with the same problem, right? For today, this is it. It is quite a hard problem to understand the bit masking, especially this is a bit masking problem. So, we'll be starting off tomorrow. Thanks for watching this live session.